Hello, fifth hour. I'm here again to talk to you about how to write up another lab. So this was the lab you did yesterday, and it was number 14, and it was the salt water. So this is Labquest lab number 14. So please pull out your lab manuals and let's take a peek at how to write up lab 14. Okay, first things first, you don't have this data table. Had we stopped and measured every one of these, the conductivity after each addition of drop, you would have a data table that recorded these values. You had the beauty of the Labquest, and so what you were able to do is the numbers are saved in the Labquest, but now we're able to analyze them. You just went and were able to put this into a graph that you now have 3 graphs, one for sodium chloride, one for aluminum chloride, and one for calcium chloride. And what we're going to do is modify one of those questions and just look at these answers. What you do have is this next slide. You have slopes. Okay? You have slopes. Now, before you get all worried here, okay, you were able to get off of your graph of your data, you were getting various slopes. Write these numbers down. I'm not sure you can see them. I'll read them. 91.5 for sodium chloride, 205 for the aluminum chloride, and 158.4. I'd like you to use these values to calculate the percent error for the reflection. And again, you only need to do one. You only need to do one of these in order to, in the reflection, but if you'd like, you can do all 3. All right. Next, what we'd like to do then is answer the questions, okay, under processing the data. So again, you have your slopes, so let's take a peek at the next item. Now, you each have an individual graph. Here's one where they're all plotted together, and it'll help us in our discussion. Right? Number 1, it said describe the appearance of each of the 3 curves on your graph. Well, pretty linear. We did a pretty good job. This is some data from some of you, and what you're going to say to answer this question then for processing the data 1. At low concentrations, the curve is very linear, right? The slope value, though, is different. Your slopes are different for each of the 3 solutions. Now, what you should be finding here, when you do peek at these slope values, okay, is that the aluminum chloride should have a nice large slope compared to the sodium or the calcium chloride. Question number 2. Describe the change in conductivity as the concentration of sodium chloride was increased. I think it's pretty obvious. As the concentration increased, your conductivity, again measured in microsiemens, was increased. What kind of mathematical relationship? That would be considered direct. Question number 3. We would like you to do just what you did in Labquest Lab 13, and that is we want you to dissociate your ions. So sodium chloride dissociated into 1 mole of sodium ions plus 1 mole of chloride ions. A total then of 2 moles of ions. 2 moles of ions. Please do the same thing for the calcium chloride and the aluminum chloride. Now, we're going to skip number 4 because you have it right here. And so what we want to know is, okay, can you do a best fit? And again, you would have needed all that data, or we could open up the Labquest again. But let's just believe us that the graph would have looked like this. Okay? For number 4. So number 4, just realize that I could send this to you, but I think we all see you can easily draw this in your lab notebook, straight lines. Number 5, though, let's answer that. Based on the graph and your recorded slopes, which graph had the largest slope value? So again, we have those values here. And I think it's pretty obvious that you should see a larger slope with the aluminum chloride. Who has the smallest? The sodium chloride. Which one? Now, since all solutions had, these were all 1 molar. These were all 1 molar solutions. So again, why would there be a difference in conductivity? When you answer this question, you probably want to include your answer here to number 3, and that would be how many moles of ions were in the various ones. Right? So that helps us write up Lab 14, Labquest Lab 14, and that should be ready to be handed in then. After you do a reflection, and so again, you're handwriting this one right in your lab manual, so you're going to restate your purposes, you're going to calculate percent error based on one of these values. One of the values, here, we always have to do this. Okay. One of these values, calculate one, you can do more if you'd like, and discuss the percent error, what went wrong, and suggestions for improvement. As always, we'd always like you to add in your suggestions for improvement. Was it valuable to learn about doing a lab write-up this way rather than being in class? Which is more valuable? Have a good day. See you soon.